Hello guys, I am Nitishres Bagalwadi, Sankalp Learning Solutions, your science teacher. In the last class, we learned or we were discussing regarding periodic classification of elements, right? Today we are going to continue it. In the last class, we discussed regarding the Mendeleev's periodic table, then triads, then as well as Newton's law of octaves, right? So today we are going to discuss regarding modern periodic table. Sorry, yeah, modern periodic table. A scientist named Henry Moseley. A scientist named Henry Moseley. Just a minute. Fine. So he gave a new property for an element which is called as atomic number. So which is called as atomic number. What do you mean by atomic number? Atomic number is it is nothing but the number of protons or number of electrons present are called as atomic number. So on the basis of atomic number, he designed the periodic table. So he gave or he stated a law which is called modern periodic law. The modern periodic law states that properties of elements are the periodic functions of their atomic number. Means properties of elements will be decided by its atomic number. So position of elements, how he grouped the elements according to the atomic number, on the basis of atomic number, how he designed the periodic table, we are going to learn now. The first point here is the modern periodic table consists of 18 groups, 7 periods. 18 groups, 7 periods. That is 18 columns, 7 rows. Fine. Then elements present in any group have the same number of valence electrons. Also, the number of shells increases as we go down the group. So elements present in any one group, the element which is present in any one group have the same number of valence electron. The elements which are present in a same group have same number of valence electron, but the number of shells increases as we go down the group. Next, elements present in any one period contain the same number of shell, also with increase in atomic number. So here, as you can see, 18 groups are there, right? 18 groups and 7 periods. Just a minute. Fine. So, fine. So 18 groups are there, 7 periods are there. So what they said, elements present in any one group have the same number of valence electron. Valence electron will be same. Then also the number of shell increases as we go down the group. As we go down the group, the number of shell increases. Hydrogen has 1 shell, lithium has 2 shells. So as we go down the group, the number of shells increases, this set. Then elements present in any one period contain the same number of shells. Elements present in any one period contain same number of shell. Then also with increase in atomic number by 1 unit on moving from left to right, the valence shell increases by 1 unit. For example, hydrogen is 1, right? When from moving from left to, let us take lithium. Lithium is 3, 4, 5. So from moving from left to right, the atomic number increases by 1 unit, increases by 1. And also the valence electron also increases by 1 while moving from one from left to right along the periods, right? Next, each period marks a new electronic shell getting filled. So in each period, you can see new electron shell to be filled. Fine. Next. So this is a modern periodic table. So here hydrogen they mentioned, and the yellow color they said alkali metals, blue color alkali earth metal, transition metal, and whatever they wrote here number, these indicates the atomic number. These indicates the atomic number. And see here, yeah. Then we have modern periodic table. What is there in modern periodic table? In the modern periodic table, the elements are arranged in the increasing order of their atomic number in the form of a table of 7 horizontal rows, which are called periods, 18 columns, which are called groups. There are 7 periods of element. you can see there are 7 periods. 1, 2, sorry. Yeah, 7 periods are there, right? So first period has 2 elements, hydrogen and helium. So as you can see, the first period. So here first period has hydrogen and helium. So this hydrogen and helium are what we can say very short period. They have a very short period. Second period has 8 elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So it has 8 elements. It is also called a short period. Third period has 8 elements, lithium to neon. It is also called short period. Fourth period, it has 18 elements. When you see the fourth, this is a third one, this is a fourth one. It has 18 elements in it. So it is called as a long period. Fifth, sixth, and sixth period is called very long because it has 32 elements. Seventh period has got 28 elements, and here you can see in the seventh period 28 elements from FR to atomic number 114 called incomplete period. See, this is called as incomplete period. Okay, why? Because okay, 14 elements each of the sixth and separately periods are placed. Here separately periods are placed related to this. Fine. Separately at the bottom of the table. The 14 elements of the sixth period from lanthanide, okay, lanthanide to luteinide are called as lanthanides. And 14 elements, these are called as actinides. Okay. So this is regarding the periods. And next, when we come regarding the groups, as we have 18 groups, right? 18 groups. There are 18 groups again, they are divided into 9 main groups. So they are 1, 2, 3, like Roman letters they have given, Roman, we can say numbers. The groups 1 to 7 has 2 subgroups, which is called A subgroup and a B subgroup. A subgroup is called as normal element, whereas B subgroup is called as transition element. And again, group 1 is called alkali metals, group 2 is called alkaline earth metal, group 3, 17, it will be having chlorine, bromine, iodine. So these are called as halogen. Group 18 will be having noble gases or inert gases. In a group, all the elements have the same number of valence electron. In group, all the elements will be having same number of valence electron. Group 1 element have 1 valence electron, group 2 elements have 2 valence electron, like that. But in a period, they will be having same number of shells. Okay, so this is regarding the modern periodic table and the modern periodic law. In the next, we are going to discuss the position of hydrogen and the position and some more about just a minute, I will just clarify it. Okay, position of hydrogen, position of rare gases, metals, non-metals, metalloids, alloys, advantages, and periods, and the group properties of it, and all we are going to study. Okay, fine. So let me end the session here and let me continue the position of hydrogen in the next session. Until that, take care. Have a nice day. Bye-bye.